Bonjour, I am Dr. Valérie Verhasselt and I am leading immune tolerance team settled in Nice on the French Riviera. I'm very pleased to welcome you to this video presentation of our work recently published in Gut. So our team studies the mechanism of gut mucosa immune regulation both in neonatal and adult life. Based on our observation with the neonate mice, we formulate the hypothesis that house dust mite may be present in the human gut and alter gut epithelium barrier, as it was shown for lung epithelia. If correct, this hypothesis would suggest that house dust mite may contribute to the pathophysiology of gut disease, which are associated with gut barrier dysfunctions such as irritable bowel syndrome and inflammatory bowel disease. To address this hypothesis, we have set up a project with Mary Tulik, a researcher specialized in translational immunology, and Thierry Piche, a gastroenterologist specialized in irritable bowel syndrome and gut barrier dysfunction.
To examine this, we sampled 6 regions of the gut by obtaining fluid from the duodenum to the rectum and measured DIRT levels by ELISA. These results have shown that indeed DIRT is present in the human gut and its concentration decreases from the duodenum to the rectum. In the next step, we examine the effect of house dust mite on gut permeability. This was done by measuring paracellular permeability of colonic biopsies to the fluorescent conjugated salt with Using chambers. This data showed increased permeability with increasing concentration of house dust mite. Knowing that paracellular permeability is dependent on the integrity of tight junctions, in collaborations with Henning Shih and Alan Walker in Boston, we examined them using electron microscopy. We've shown disruption of tight junctions following house dust mite exposure. Immunofluorescent images show the decreased expression of both zonooccludins and occludin tight junction proteins following house dust mite exposure. We know that house dust mite disrupts lung epithelia by serine and cysteine proteases. Therefore, we inhibited enzyme activity using selective inhibitors, AEBSF for the serine protease and E64 for the cysteine protease. These results have shown that increased responses to house dust mite are abolished by cysteine and not the serine proteases. We know that house dust mite drives allergic reactions in patients which are sensitized and have house dust mite specific IgE. We wondered if allergic sensitization was required for house dust mite impact on gut permeability. As you can see, both allergic and non-allergic subjects respond to house dust mite, suggesting that prior sensitization is not required. We next asked what would be the impact of house dust mite in patients with compromised gut barrier, such as in patients with irritable bowel syndrome or IBS. We found that gut permeability is further compromised in IBS subjects following house dust mite exposure compared to control non-house dust mite exposed IBS mucosa. Next, we wondered if this increased response to house dust mite was associated with increased inflammatory responses. While in healthy people, house dust mite induced predominantly an IL-10 response, in IBS patients, this response was predominantly pro-inflammatory, driven by TNF.
To conclude, we can say that yes, respiratory allergen, and in particular, the one from house dust mite can be found in healthy human gut. By their proteolytic activity, house dust mite antigen may represent an important environmental trigger for initiation and or maintenance of gut inflammatory disease. Our work should now foster epidemiological studies looking for association between house dust mite exposure and the risk for irritable bowel syndrome and inflammatory bowel disease. Our observation opens new perspective for therapy. We may consider to target house dust mite cysteine protease, but also to propose environmental control of respiratory allergen exposure for irritable bowel syndrome and inflammatory bowel disease treatment. Bonjour, I am Dr. Valérie Verhasselt and I'm leading immune tolerance team settled in Nice on the French Riviera. I'm very pleased to welcome you to this video presentation of our work recently published in Gut. So our team studies the mechanism of gut mucosa immune regulation both in neonatal and adult life. Based on our observation in the neonate mice, we formulate the hypothesis that house dust mite may be present in the human gut and